Hello everyone, my name is Kasra Abbaszadeh, and for a few minutes I want to talk about my project, the Nash Stablecoin, which is built using the Lisk SDK. At first, I want to thank the Lisk team for this great opportunity that I can share some of my experiences with you. In this presentation, at first we will have an overview on different types of stablecoins in the market, a little about the Nash project and its stability mechanism, and finally some of my experiences with Lisk SDK. As you know, one of the major problems with current cryptocurrencies is the price fluctuation, which prevents companies to use them in their financial systems. One way to overcome this problem is using stablecoins, and today generally we can categorize stablecoins in three types. One is fiat-backed stablecoins, which means that a company or several companies create a central reserve of fiat currencies or special commodities like gold with a central control on reserve supply to back the stablecoin. But because of the centralization, they have problems like low transparency and single point of failure. The other type is crypto-backed stablecoins, which use a decentralized reserve instead of central reserve. And users can lock up their crypto assets in smart contracts or blockchain applications in exchange of some amount of stablecoin. This type is vulnerable to crypto assets price volatility, and also because of decentralization, the mechanism design here is very difficult and complex. The other type is algorithmic stablecoins, which means that we use some algorithmic methods to manage the supply, particularly to contract the supply in low prices and expand the supply in high prices. But the pure algorithmic stablecoins are vulnerable to black swan events, which means that in much low prices, the contraction of supply will give a positive feedback and decrease the demand, and this will cause the system destruction. In the Nash project, I tried to build a proof of concept, somewhat backed, and also algorithmic stablecoin. In this system, we have three types of tokens: Nash, Bond, and Share. Nash is the core token of the system, which is pegged directly to US dollar. Bond is a non-fungible token which is released in low prices, and Share is a community token for investors in the system's reserve. The high-level idea is that when the price of Nash is under the peg, some new bonds will be created and released to the market automatically. The bonds are only purchasable by Nash tokens, and they have some offers in their price that will encourage the users and arbitrageurs to buy bonds. This will cause a contraction in Nash supply, and the price will be increased to the peg. And also, when the price is much low, we can use a Lisk reserve to buy Nashs from market and burn them to return the price to the peg. And when the price of Nash rises over the peg, the supply will be expanded in two ways. First, some previously sold bonds will be converted to Nash automatically, and also some new Nashs will be generated and airdropped to shareholders of the system. The current implementation of Nash is based on Lisk SDK version 5 and support these functionalities. Users can price the system with different values and test the stability mechanism, contraction and expansion functions. They can purchase bond from market bonds, unsold bonds from bond market, and they can invest in the reserve, buy share tokens or sell them back. And also they can transfer the ownership of bonds or transfer Nash tokens to other accounts. The management mechanism for reserve has not implemented yet. But why I choose Lisk for building the Nash. One of the benefits is complete and great documentation and very useful tutorials that help the developers to learn syntaxes and functionalities very fast. And also they have an open and active community which supports the developers, and also the development kit is growing and one of the powerful SDKs in blockchain area. And also the Lisk SDK is based on JavaScript, which is much easier to learn and work than some other languages like Solidity programming language or other dedicated languages in different blockchain development kits. And one of the major benefits of Lisk is its modular architecture, which gives the developers the ability to creating new transaction types, new plugins, new blockchain layer logics in their custom modules. And also about the last upgradation of Lisk SDK, I have some experiences with both SDK version 3 and 5. If I want to compare them, in version 3, developers implement their business logic through custom transactions that are registered to the blockchain. But in version 5, we have custom modules instead of custom transactions, which are more general and contains, in addition to custom transactions, contain custom actions, reducers, events, and account schemas. In version 3, the database was based on PostgreSQL, but in version 5, it's abandoned and much simpler to work and debug. And also because of new actions, reducers, or events that can be defined in custom modules and that are exposed from blockchain side of application and accessible from running nodes and front end side of application, the module to module communication is now much simpler and much possible than previous versions, and this is a great improvement toward the final stage of Lisk SDK. If I want to summarize the talk, first we introduced the Nash as a somewhat back and also algorithmic stablecoin which use mechanisms to maintain its price stability without requirement for central control. And also we talked about some major features of Lisk SDK as one of the leading blockchain development tools in the area. Thanks a lot for your attention. The source code of Nash Project is available on my GitHub address, and if you have any questions, you can find me in Lisk server on Discord. Thank you.